Hi, I'm just going to try to explain this now. I've never done a video like this before, so work with me. So using the law of sines to solve a triangle, just to review that solving a triangle means to find every side and every angle in this triangle. And it's possible that there could be more than one triangle with a given condition. We're going to use the law of sines to do this when it's not a right triangle. So a quick review of the law of sines. The formula is a over the sine of A is equal to B over the sine of B is equal to C over the sine of C. And in your book, when you do this homework assignment, they use these Greek letters to represent the angles. So anyways, for the first example, it's given that the measure of angle B is 30 degrees, side A is 6, and side B is 2. So if you draw your picture and see what you can try to find with the given information, you can try to find the measure of angle A. So I started with the formula for the law of sines. I solved it for the sine of angle A because that's the angle that I'm looking for. When I put the information in and worked out the value of the sine of A, it was 3/2. There can't be a triangle because the sine value can't be greater than 1. So here is just a summary of the given information. Side B was given it was 30 degrees. Side A was 6 inches. Side B was 2 inches. I was trying to find side A. I couldn't find it because the sine value was greater than 1. For the second example, here's a picture of what's given. And on my chart, I filled in with red the given information. The first thing that I was able to try to find with the given information was the measure of angle B. So I started with the law of sines. I solved it for the sine of B. I filled in the given information, and I got that the sine of B was 0.957, etc. Then I did find my reference angle in quadrant 1. So I did inverse sine. I used the answer from the step above, and I came up with 73.246 degrees. Now that's my theta prime. But because sine is positive in both quadrant 1 and 2, I had to consider this in both quadrant 1 and 2. So in quadrant 1, it was 73.247 degrees. In quadrant 2, I used 180 minus my theta prime. So in quadrant 2, angle B could also be 106.753 degrees. So when I go back to my chart, here's one of the values I found for angle B in quadrant 1. Here's the second value. Because these don't add up to 180 degrees yet, I subtracted those to find angle C. Here's a second situation where these don't add up to be 180 degrees, so angle C could also be 23.247 degrees. So what's going on here is we have two possible triangles with the given conditions. After I determined that there was two triangles, I had to find side C for both of my triangles. So I'm going to go back over here to the work. I've already explained how you found side C. You subtracted angle A and angle B from 180 degrees. So here's our first value for the measure of angle C. I wrote down the law of sines again. I solved it for sine C. I filled in the given information. Now, for the sine of C, you can't use the rounded value. You have to go back to this unrounded value up here. So you're going to have to do this while you still have that on your calculator. And when I solve for the side C, I got one value to be 4.367 feet. So here's one situation. Then I went back and I had to redo the calculation in my calculator again, so I had the unrounded value for the measure of angle C. I filled into the law of sines again. I found the second value for the side C. For example number 3, with the given information, here's my triangle. I was given that angle B was 78 degrees, side B is 23 meters, not degrees, it should be meters, and side C is 20 meters. I filled in the information, assuming there could possibly be more than one triangle. From what's given, I could find angle C. So here's my questions to find angle C. I solved it for the sine of C. I filled it in. I came up with the value of the sine of C. Then when I did second sine with this answer, I got my reference angle in quadrant 1, which is 58.272-ish degrees. So in angle 1, here would be the value of angle C. In angle 2, because this sine value was positive, in angle 2, the measure of angle C would have been 180 minus theta prime, so it's 121.727 degrees. Okay, let's stay over here now. If I did that, and I had 78 degrees for angle B and 121 degrees for angle C, together these already add up to be more than 180 degrees, so there can't be a second triangle in this example. If I go back to the measure of angle C in quadrant 1, again, I have to redo the calculations, so I use unrounded values. The measure of angle A is 180 degrees minus the 78 degrees for angle B minus the unrounded value for angle C. Don't use this, use your unrounded value for angle C. And here's what I came up with the measure for angle A. So rounded would be 43.727 degrees. Running through the law of sines, I found the side of A. You always have to use your unrounded answer. So even though after you wrote this down and you wrote this down for a rounded value, when you use it again to find the side of A, you have to use that unrounded value. And there's the measure of side A.